So now that we're getting pretty used to using that power rule, which is pretty much just the same as the derivative power rule, but in reverse, now we're going to take a look at some antiderivatives involving exponential functions. Remembering that the derivative of e to the x is e to the x, it's probably not surprising that the antiderivative of e to the x dx is just e to the x plus a constant. The antiderivative of a to the x dx is going to be a to the x over ln of a plus a constant. Let's look at the derivatives of these answers a little bit closely to verify that these are the correct rules. So let's take the derivative with respect to x of e to the x plus c. So if we take the derivative of e to the x and add that to the derivative of the constant, we get e to the x. And that was the integrand of our original antiderivative, so this must be the correct rule. If we were to take the derivative of a to the x over ln of a plus c, we'll break it up the same way, except now we'll pull out the ln of a as 1 over ln of a times the derivative of a to the x plus the derivative with respect to x of the constant. So when I work out the first term, the derivative of a to the x with respect to x is ln of a to the x. Remember, the derivative of our constant will be 0, and notice that the ln of a's cancel out here, leaving us with a to the x, which was our original integrand. So this verifies our rule that we talked about a little bit earlier. So let's use those rules. Let's take the antiderivative of 2 times e to the x dx. So the first thing I'll do is I'll pull the constant 2 out in front and take 2 times the antiderivative of e to the x dx. The antiderivative of e to the x is just e to the x, multiply by the 2, and now add our constant on. So there's our antiderivative. In the antiderivative that I see below here, I want to find the antiderivative of e squared plus 3 times 2 to the z dz. I've changed the variable here to try and cause you a little bit of confusion. So the first thing I'm going to do is I'm going to go ahead and break the sum up into 2 antiderivatives. So the antiderivative of e squared dz plus the antiderivative of 3 times 2 to the z dz. I'm going to pull my constants out, and this might scare you a little bit. E squared is just a number, so I pulled that out in front and left a 1 on the inside. So we have e squared times 1 dz. Pulling out the constant 3 in the other term, that's what we've been doing before, so we're going to add to this 3 times the antiderivative of 2 to the z dz. So now when I complete those antiderivatives, the antiderivative of 1 with respect to z is simply z because the derivative of z is 1. So we get e squared times z. The antiderivative of 2 to the z is going to be 2 to the z over ln of 2, and now I put my constant in front. And then I remember at the end to add my integration constant. Now let's make things even more complicated. And this is going to start to lead us into what we're going to need to do in the next section, 15.2. I want to find the antiderivative of e to the 3x dx. What most people guess the antiderivative is here is they think it's e to the 3x plus c, because you're used to doing derivative of e to the x is e to the x. But let's check that. If I take the derivative with respect to x of e to the 3x plus c, I need to use a chain rule. And so I take the derivative of the e to the 3x, I have to multiply by the derivative of the inside, and I get 3e to the 3x, and that does not match my original integrand. So something must be wrong. So what if I change my antiderivative and put a 1/3 in front of it? So when this 3 comes out, it's going to cancel with the 1/3. So I'm now thinking that the antiderivative of e to the 3x dx is going to be 1/3 e to the 3x plus c. Now when I check it, I'm going to say that my inside function, g of x, is going to be 3x. My outside function, f of x, is going to be 1/3 e to the x. So g prime of x will be 3. And f prime of x is going to be 1/3 e to the x. So my derivative here is going to be 1/3 e to the 3x, and then I multiply by the derivative of the inside, the g prime. The 3's cancel out and leave us with e to the 3x. And that matches with my integrand. So that tells me that the antiderivative up here is 1/3 e to the 3x plus c.